It looks like everybody's already being back inside, so let's start and let's welcome Cliffano on stage from Australia with this talk about introducing AEM OpenCloud as a solution. Let's welcome Cliffano.
Thanks everyone for being here for this talk. This is an introduction to a project called AEM OpenCloud. My name is Cliffano Subagio. I'm from Shine Solutions in Australia. So just a little bit to start with. This is Australia. We all wear hats like this, and we all have crocodiles in our backyard. This is called a cobra hat. A little bit about us. So Shine is an Adobe Community Solution Partner, and we have been doing AEM infrastructure projects on AWS since 2013. I'm a senior consultant at Shine Solutions, and I created the project, and now I'm one of the core contributors to the project. So what is AEM OpenCloud? So to start with a brief timeline, so our first AEM infrastructure on AWS was a project in 2013, 2014. Since then, by the third project, we've identified a number of common problems, common patterns that all of the projects ended up having to solve. But the problem was that because each project is funded differently on different clients, then you have to start from scratch. We ended up doing it better, but we ended up having to rebuild the similar solution over and over again. So in 2016, we decided to start open sourcing gradually the solutions piece by piece with the idea that the next project can reuse these open source solutions to build a better and improved solution for the next project. So as of today, AEM OpenCloud is running in production at 2 banks, 2 insurance companies, and another government organization in Australia is currently adopting it. The ultimate goal for this project is to have a fully automated solution that is ideally no manual effort to do things for managing multiple AEM environments with just clicks of buttons. And what is AEM OpenCloud itself? So there are many factors as part of the project. So one is that it is an open source solution. It is an infrastructure platform. All code is on GitHub, licensed as APACHE2, and it should be commercial friendly enough, and there is no vendor lock-in. So if a user wants to fork off a solution, that's perfectly fine. That's why it's open source. And all packages are published through open channels. So some artifacts are published to GitHub, some to Maven repository, some to, Maven Central, some to PyPy.org, RubyGems.org, npm.js.com, so all the public channels for the various open source technology stacks. Even though it's a modular design, this platform is designed in a modular way, but the focus is on AWS just because it reflects the current, I guess, market distribution for the various cloud solutions out there. It becomes a building blocks for other platforms as well. So there was a user from Canada who ended up using parts of AEM OpenCloud for their own AEM solution on GCP. Another company is reusing parts of the libraries, for example, for provisioning AEM itself, and then integrate that into their own architecture. And that's perfectly fine as well. That's the whole reason why we attempted to open source this solution so that hopefully it can help to better the next and other projects. It currently supports multiple AEM versions. So out of the box, we can build AEM 6.2, 6.3, 6.4, 6.5. So the idea is that it attempts to provide a flexible migration path. So for example, one of our users actually has 3 different groups within the organization. One is still running AEM 6.2. The other one is on 6.3. The other one is on 6.5. The project from 6.2 is being upgraded to 6.5. So they need to run 6.2, 6.3, and multiple 6.5s at the same time for multiple projects. So that's where I guess the need for having multiple AEM versions being supported from the platform came about. And on top of that, it also supports multiple operating systems. So at present, it supports Amazon Linux 2 and Red Hat 7. There is an experimental CentOS 7 support, and Red Hat 8 is being worked on. The idea of this is to, I guess, provide the user with the flexibility on choosing what sort of operating environment they want to use. So for production, many enterprises decided to choose Red Hat, which probably a bit more expensive, right? But in order to save costs, they can run their non-production or pre-production environments using Amazon Linux 2. And they can save a bit of cost from that point of view. Why does one want to use AEM OpenCloud? So if you currently don't have any AEM on AWS, but you need to run it within your boundary, then it provides a production-ready code. It's an accumulation of 5 years of experience. And I know line of code is not reflective of the size of a project, so it has about 126,000 lines of code, not in Java. So if you rewrite this in Java, it's probably 1 million. It also provides the ability to run AEM infrastructure within your perimeter. So you don't rely on, I guess, a provider's setup of the environment. You can run it within your own SOE, using your policies, your practices, and your compliance requirements. So a number of enterprises need to be audited every, I guess, end of financial year, and each one tends to have different audit requirements. And the platform is flexible enough to be able to be customized to fit these various audit requirements. AEM OpenCloud is highly configurable, so it has hundreds of configuration parameters with hopefully sane defaults. And it also has multiple build and runtime customization points. So the idea is that if one project is using, for example, Splunk for their logging solution, right? Another one is using Datadog. Even though AEM OpenCloud provides the ability to provision the AEM infrastructure, but it provides customization points. So it's like plugins. So when you create the machine images, you can also install the Splunk agent or the Datadog agent. But the idea is that if you have 5 projects with different requirements of these logging solutions, then they can reuse the AEM layers in the same manner. Oops. And there is also a focus on security and testing. The architecture design has a minimal blast radius, which I'll jump into a bit later. And the library code base, the infrastructure environment testing, we have various unit testing, integration testing, and the machine images themselves and the environments are tested using inspect. So it checks if we install AEM, then is AEM running? Is it listening on the right port? Is HTTP or HTTPS is working? Other than that, being an open source solution, it also relies on tons of other open source libraries out there. And with that comes the challenge of making sure that the dependencies are probably in a good state of, as in it doesn't have vulnerabilities, like well-known vulnerabilities. So we do have regular scanning of the various sub-dependencies of the various projects that we have in AEM OpenCloud. The goal is always, obviously, to not have a dependency that has known vulnerabilities. So how does it work? In summary, it has a component called AEM OpenCloud Manager. So it can be replaced by any CI/CD tool. Some of our users just integrate the platform with their own Bamboo installation, for example. So you use the AEM OpenCloud Manager to create machine images. So in this case, create AWS AMIs. And then using those AMIs, you can then create AEM environments. So this is a combination of 6.2, 6.3, 6.4, 6.5 that you want. And then you can run various tests against the environments. And you can run operational tasks against the environments, like deploying or flushing the case, enabling, disabling CRXDE, anything on demand. So what is AEM OpenCloud Manager itself? So it is basically a set of ready-made Jenkins pipelines that you can just provision into your Jenkins installation to run AEM OpenCloud ecosystem. It's just Jenkins just because majority of our users are using Jenkins, but yeah, it can be extended to support other CI/CD tools. So let's have a quick look at AEM OpenCloud Manager. So I have a Jenkins instance there. So at the top level, oops. So there is that folder, AEM OpenCloud 4.10 pre-release 6. So that's the latest version. As the user upgrades their AEM OpenCloud platform, there will be a different folder with a different version. So if some of their environments were built with the older version of OpenCloud, and that's already in production, they need ongoing maintenance releases, so they can do it that way. And then for the next platform, then maybe they upgrade AEM OpenCloud, so there is another folder that it can have in parallel. So under the folder, there are several sections. So the first one is to install the libraries that AEM OpenCloud uses, and then you can create machine images. You can then manage your environments. There is a migration section there for importing AEM installations that are not managed by AEM OpenCloud. And there are also a set of operational tasks that you can then apply on top of it. And then you can run multiple levels of testing. I'll jump into each of these sections as we go through the presentation. So let's start with the machine images. These machine images are built using one of the repository within AEM OpenCloud called Packer AEM. So under the hood, it's basically a set of Packer templates, which are configurable. And it supports the build of using AWS AMI. There is experimental Docker support, but because AEM does not officially support Docker for production environment, for example, so it's just experimental because it's there because we believe, well, Packer is flexible enough to build multiple types of machine images, and we also do believe that at some point AEM will be looking at container solutions. So it's an anticipation. So separating the machine images from the environments allows us to install AEM just once per version, per combination of operating system and various service pack levels. But the idea is that once you install AEM on the machine images, you can then use the same machine image to create multiple AEM environments. Roughly, the dependency structure looks like this. So you have a source machine image. So that can be an AMI from AWS Marketplace or your own organization's AMI. So for example, one of our users has a standard operating environment that enforces all projects to rebuild their machine images every 3 weeks. So this is the flow. They just update the source every 3 weeks and rebuild all the environments. It builds an AEM author, an AEM publish, an AEM dispatcher. And there is also one machine image that contains a single AEM author, AEM publish, and AEM dispatcher on one server. And there is also a Java AMI for some utility tools that we added to the architecture. The other thing that we introduced is also this notion of AEM profile. So the format looks like this. So it has AEM and then service spec number and cumulative fixed spec number. The idea is just to simplify on how users want to specify what AEM version with service spec level with the various hotfixes that they want to have within the environment. So this ends up with just a YAML configuration value. So if the users want to slice their environments, right? So some uses AEM 6.2, some use AEM 6.3. They just specify these profiles. And then the profile translates the installation of this, let's say AEM 6.2 or AEM 6.5 quick start jar, and then it installs service pack 1. It performs various level of checks. So if it is executing an upload of the service pack package, it checks until the package is uploaded. And then it moves on to the next state, install, and then it checks until it is installed. And there is various level of AEM readiness checks as well. Obviously, from the previous talks, we all know that it's not something that can be perfectly done at this point of time. And to shout out to Brian Stopp from Adobe for building Puppet AEM. So we used to have a similar module that we used to maintain in the past, but happy to switch to Puppet AEM module from Brian. And that is used at the core of the AEM provisioning logic within AEM OpenCloud. OK, let's quickly switch to the Jenkins demo. Now, if we jump into the machine images section, so there is an AWS option there with the thinking that at some point in the future, hopefully there are other cloud providers options. So you can see multiple options there. A permutation of the operating system and the AEM versions. So with this installation of OpenCloud Manager, you can build Amazon Linux 2 with AEM 62345, right? AWS Red Hat 7, AEM 62345. And out of each of these environments, so if I pick a Red Hat 7 AEM 6.5, I have the options to build the various components, author, publish, and so on and so forth. And building is just, yeah, I'll just like author, and then build, and then build. So that will kick off, and behind the scene, it will create an AMI with that configuration in your AWS account. Obviously, not all users will need the permutation of those AEM versions and operating system, but that can be configured. So AEM OpenCloud Manager installation is actually based on a user YAML configuration. So if your organization only needs AEM 6.5 on Red Hat 7, that can be done, so you don't worry about the other options. OK, so let's switch back to the next section. Now, AEM environment architectures. AEM OpenCloud supports 2 architectures, but the design allows us to, I guess, create more architectures in the future. So this is what we call a full set architecture. It has an auto-scale group of author dispatcher, publish and publish dispatchers, with an author primary and author standby. This is suitable for production and pre-production environment. Some users end up having 20 of these just because they want the, I guess, production-like environment as early as possible in their continuous delivery pipeline, and that's fine, but it's costly for it, obviously. There is an auto-recovery support. So if, for example, an author dispatcher is terminated there, the event will then be sent to SNS topic and SQS queue, and there is a component there called the orchestrator that will react to that event. So, for example, if an author dispatcher is terminated, then it will clean up the old flash agent that used to exist on the author primary. And then when the auto-scaling group creates a new author dispatcher, the orchestrator also knows. So, hey, there is a new author dispatcher. I'm going to create a new flash agent on the author primary. So that's how it manages the reactiveness of the environment, I guess, dynamic aspect of the environment. And same thing with the publish and the publish dispatcher. So they are paired just for this architecture. And if a publish instance is terminated, then the orchestrator will clean up the replication agent that used to point to that environment. And then it will terminate the old dispatcher pair. And a new pair will come up, and it will recover by itself. There's also an auto-scaling. If the CPU is running really high on, for example, a dispatcher, then it will scale out and create more pairs. It has a blue-green deployment capability. So so the idea is that out of one environment, we can create snapshots out of it, and then create a copy of the same environment. So so that allows a level of flexibilities on our various users' use case. It also has multiple level backups. It can create AEM package backup. So we introduced the notion of an export descriptor. So the idea is that you specify a definition of, I want this backup package 1. And backup package 1 define a series of paths that you want to include in this backup. And you can define multiple of these. And there is a scheduled job inside its environment that will create these packages. And out of these packages, you can export, and then you can import to another environment. So it's kind of handy for like training environment, for example. If you just want a set of data from one environment to the other, but you don't need the whole repository. There is also a live AWS EBS snapshot. So this is an EBS snapshot that's taken when AEM is up and running. The idea is that the more frequent you take the snapshot, then the faster it is for the next snapshot to be taken. But having said that, we know that the repository sometimes ends up in an unhealthy state. So we also introduced an offline AWS EBS snapshot. So this is where, and you can schedule this. Usually users schedule this a bit closer to midnight. So the idea is that AEM will be stopped, and the orchestration allows us to, for example, stop an author, stop a published instance, and then take a snapshot when AEM is not up and running. Now, other than full set, we also introduced this thing called a consolidated architecture. So this is just a smaller AEM environment, just a single server that has an author, a publisher, and a dispatcher. So the idea is just because some of our users end up with so many environments which are production-like, but they do not need the production-like capabilities. So they started introducing consolidated architectures in development and test environments, because obviously it's a low footprint, so much lower cost. Rather than, for example, 10 servers, you just have one. And one use case where it is used is for branch regression. So, for example, one of our users has like 5 development teams working on various feature branches. Whenever there is a pull request being merged, the code will be packaged, and then a new consolidated environment will be created. The code will be deployed there, and then the regression test will kick in. And then at the end, the environment will just be terminated, so it's gone. So the lifetime of this small environment is only during the how long your regression testing runs. So if you combine this with Amazon Linux 2 operating system, then you're not paying for the full hour for the cost of the environment. So yeah, so the more pull requests are being merged, then the more short-lived environments of this type will exist and then will be destroyed, exist and then will be destroyed. Another part of the whole architecture is what we call an AEM Stack Manager. So this is a simple message broker. So the idea is that this becomes an entry point from the CI/CD tools. So any message that is sent to the environment goes through the broker first. And then it will then execute a set of Lambda functions that will coordinate through AWS SSM to then execute the commands from within the environment. So there is no, I guess, external request coming in directly to AEM author, for example, just for example. The message always goes through SSM first, and then the instruction is executed from within each of the AEM instances. So rather than specifying the destination as AEM author IP or DNS names, it will just always operate against localhost. Yeah, so AEM Stack Manager is used to manage multiple AEM environments. A common setup is that there is one Stack Manager per AWS VPC, but the users are free to map whether it's one-to-many or one-to-one for each of these Stack Manager to the environments. And yeah, so at the core, it's using AWS SSM for executing the various commands. So as a whole, the OpenCloud system looks like this. So you have a CI/CD tools that creates machine images, and then the machine images are used to create the various environments. So you have the full set, could be many of them. You have consolidated environments, could be many of them. And the Stack Manager is used to manage all these environments. OK, so let's have a look quickly for the environments management. OK, so we jump onto the Manage Environments folder. And yep, so you can see the options there. Again, combination, permutation of the operating system and the AEM versions. And you can create consolidated or full set environments for each of the permutations. So you can create multiple architectures, multiple operating system, multiple AEM versions just in parallel. Let's have a look at one of these quickly. Oops, not this one. Yeah, so it looks a bit like that. So this is just an example pipeline. Jenkins doesn't have a nice view, so I just switched to a nicer view called Blue Ocean. So you can kick off, initialize the pipeline, prepare the libraries, so on and so forth. It creates the AEM environment and then run various acceptance tests. So acceptance test checks whether, for example, the AWS resources are created or not. For example, is the CloudWatch log streams being created? Is the environment is complete? So if it's meant to have 3 author dispatchers, does it have 3 author dispatchers? So yeah, it will deploy the application, flush the cache if needed, and yeah, perform other checks along the way. So that's for the environment management aspect of it. Now, there's also one bit called operational tasks. So these tasks are basically just an accumulation of the things that either the DevOps team, SysOps team, or release managers in our users' projects that they had to do. So we turn them into, I guess, automated pipelines. So you can deploy packages to these environments. You can export, import packages. You can flush the cache. You can create snapshots out of it. And then you can trigger offline compaction, for example, on demand. And you can enable, disable SAML. So some of our users, they do have SAML, but they don't want to use SAML for all of the environments. So it provides a level of flexibility to be able to, on demand, enable, disable SAML. Same thing, enable, disable CRXDE, promoting an author standby to author primary. In terms of deployment itself, we also introduced this notion of a deployment descriptor. The idea is that you can define an AEM component and then a set of packages that you want to exist on that component. So in this example, for the author primary, I want to have this AEM Hello World content package of version 001. And you can define whether you want to replicate the package or not, or you want to activate, or you want to force the installation of this package. And this is to solve a problem that we had in the past where one project attempts to have like 2 super AEM packages. They are larger. Another project wants to break down the AEM packages into 15 smaller ones, right? And managing the differences between them becomes a communication complexity problem. The release manager is often blamed when a package is deployed out of order. So this array, along with the various checks, helps the users to identify that, let's say the sequence is you deploy package A, B, and C. So package A is deployed, installed, make sure it's really there, it's installed, and then move on to the next one. So the sequence is guaranteed. And this descriptor, our users actually generated them automatically out of their build process, and then put them in source control. So each one is versioned. So when a user sign off on a pre-production environment and then goes to production, they don't talk about, I want this package A, B, C, and D. They just say, I want deployment descriptor version 1.2.3. So when they go to production, the language is the same. They just say, I want deployment descriptor 1.2.3, and that guarantees that the same set of packages will exist on the destination environment. I'll probably skip this one on Jenkins one, because basically the operational task screen has each of the operational tasks that we supported. Okay, so moving on to platform testing. A question that one of our users asked in the past, because traditionally enterprises have a really long, release cycle, right? So they only, let's say, upgrade the environment every 6 months, for example. And we want to speed it up. So we want to be able to say, just upgrade to the next version of the AEM OpenCloud. And a common question that they ask, how do they know that it will work, right? Because let's say we tested it outside of the project's environment, and it's working. But combined with the user's applications, things might not work. So to answer that question, we introduced various types of testing. And with the idea is, for the users to be able to run multiple testing on their own so that they have the confidence that the platform is working within their AWS account, within their environment structure, within their timeline as well. One testing that we introduced is, and this is to answer a problem with audit. Many traditional enterprises has an audit requirement to perform your DR testing, disaster recovery, at the end of the year, right? Once a year. And that often ends up as a chaotic process because everyone panics and then everyone has to retest everything. So rather than waiting for the end of the year, we just introduce Chaos Monkey into the architecture. So it is just configured to run. User can configure it to be as aggressive or not as aggressive as they want to. So a common setup is they only enable it to terminate at most one server at random, and it's only done during business hours. So let's say if something goes wrong, someone is there. And the idea is that you can configure the Chaos Monkey to terminate either of the author dispatcher, a publish dispatcher, or a publish instance. And this is set up and running in production. So that should give them a level of confidence that when the real problem happens in production, let's say an EC2, a hardware piece is failing within AWS. So at least it is continuously tested. And users shouldn't be worried and shouldn't wait until the end of the year for the audit in order to be able to test that. A different type of testing that we added is a security guideline testing. So this is an attempt to implement some of the AEM security guidelines. For example, checking whether X-frame options is set to same origin. These administrative related paths shouldn't be accessible, right? So this actually saved one of our projects from one of our users. Someone accidentally set, rather than blacklist everything, disallow everything, it's accidentally set to allow everything. And this test pick it up because the build will fail. This is implemented using a library called inspect, and it implements the various controls that attempts to, I guess, follow the AEM security guideline. And the idea is obviously for every release, the users have to pass the AEM security guideline. Another test is called recovery testing. With Chaos Monkey, there is an element of, I guess, probability and chaos behind it. And that's why it's just run in production, and it just randomly attempt to cause chaos, right? But a common question is, like, how do we know that all the recovery points will be working? Because they can't wait for Chaos Monkey to terminate all of them, right? And that's probably not going to happen as well, because it's really random. So what we introduced as part of AEM Test Suite is the ability to just systematically terminate one author dispatcher instance, wait until the environment is back to ready, terminate one publish instance, wait, terminate a publish dispatcher instance, wait. In fact, it has like terminate itself. So terminate the test, terminate the orchestrator, wait until it's back, and same thing, it also terminates Chaos Monkey itself. So yeah, so that is that, again, the users should have a level of confidence that the system can recover. BlueGreen testing was introduced to answer the question, same thing. How do we know that the BlueGreen feature is working? So this test pipeline creates a simulated green AEM environment. So we just pretend there is an AEM environment there. And then we take snapshots out of it. So create a snapshot for an author environment, and then create another snapshot for published environment, and then use those snapshots to create a pretend blue AEM environment. So the idea is that we should always know that the blue-green capability actually is working. Okay, so just to quickly show you. So if we go back to Jenkins, then we have a section for testing. And Again, AWS, again, the various combinations. And then, yeah, you have to just test. So if you just click one of these test pipeline, then it will just perform those various testing. So yeah, so you can test the BlueGreen, the various platform testing, acceptance testing, and recovery testing against a combination of your AEM environments, right? AEM 62345, Red Hat, various operating system, and combination of architectures as well. Now, security, right? So a critical piece of the architecture design is the minimal blast radius. So the idea is that there are only 2 entry points, and they don't have to be public. So from the CI/CD tools point of view, rather than reaching an author instance or a published instance directly, which opens up, I guess, a hole to your AEM instance, you just point it to an SNS topic. And then you can just lock down the permission to guarantee that no one else can access that SNS topic. The message broker, Stack Manager, will then translate that the payload that is sent to the SNS topic and then perform the action accordingly. So a simple payload could be, I want to flush the dispatcher cache. So the message broker then translate that command and then execute to tell the dispatcher instances, author dispatcher and published dispatchers, to then execute the flush dispatcher cache within itself through SSM. So there is no, I guess, poking directly to any of those instances. So that's coming from the CI/CD tool. From the other end, there is a load balancer sitting in front of the published dispatcher. So that doesn't have to be put in a public subnet. It can be placed within a private subnet, depending on, I guess, your environment requirement as well. Some environments require a public ELB because it needs to be integrated with an external CDN. So that's fine too. Some users actually has a generic web layer that sits within their perimeter, and then that allows them to put the published dispatcher ELB within their private subnet, and that's great too. So there is one entry point from the outside for accessing, I guess, the content of AEM, the published content, and just a second entry point directly to Stack Manager SNS topic. And those are the only 2 entry points. Other security features that are built in, every time you build an AEM environment, the system user passwords, the admin user, the orchestrator user, replication user, they're all random, and they're unique. So if you create 20 AEM environments, if one of them is hacked, then the passwords cannot be used to hack the other environments. And our users actually don't know what is the admin password. Well, assuming they have set up the proper ACL and permission and user accounts, right? So they only need to find the admin password for a break glass situation. So they'll just dig it up in the system. It has a first-class SAML configuration with Okta integration to be set up soon, within early next year. EBS volume is encrypted. DynamoDB, so various encryption that can be done on various AWS resources are set. And it also has a customizable load balancer cipher suite, just because various security requirements keep changing as time passes by. And obviously, SSL communication between the various AEM components. So replication is done through SSL, data sync through SSL, yep. And dispatcher talking to published instance, that's through SSL as well. There are some monitoring capability. So within the environment, it actually sets up CollectD that will make AEM JMX bins available as CloudWatch metrics that are then can then be hooked up to various monitoring tools. There are a lot of CloudWatch alarms set up with SNS topics. So some of our users just simply subscribe their emails to the SNS topics, Some hook it up to a notification system that will send a Slack message whenever there's an alarm. So yeah, various level of integration. There are CloudWatch logs as well that can be hooked up to other log analytics tools. And there are also CloudWatch dashboards. Now, coming back to AEM OpenCloud itself, we attempt to have a modular design, and it's roughly sliced this way in 4 layers. At the very bottom of it, that's what we call the AEM API layer. So basically, that's anything that interact with AEM, we hide it behind an API client that can be tested and integrated with various technology stacks. And then on the next layer is the AEM provisioning. So we want to not stop at just provisioning a single AEM instance. So it needs to know whether it's an AEM instance that sits within a consolidated architecture or within a full set architecture. It knows whether it's a published instance or various level of the AEM environment setting. On the next layer, the third from the bottom, is the AWS Cloud Platform. So the AWS-specific implementations, they're all separated into different repositories. So this allows one of our, I guess, part users to actually use the other layers and then integrate them to their own GCP implementation. And at the top is just the AEM test suite. So this is just the various testing that can be done, well, in theory, to not just AWS infrastructure, right? So just AEM on-prem or any AEM installation should be fine. Not expecting you to read this, but so this is just to just a high-level view of the repositories breakdown. So it's really broken down into various, I guess, logical pieces. And even though, well, most of our core users are adopting the whole thing within the tree structure, some of them actually just, let's say, integrate the Puppet AEM curator layer downward and then integrate the solution into their own architecture. And that's fine. We're happy with that because at least it's useful for the AEM community. Where do we go from here? So our goal is to provide the community with an open platform to run AEM environments within the user's perimeter, right? So it's an alternative solution. If a user really has to run their environment within their boundary to fulfill their own requirements or audit, sometimes something is you can argue with certain audit requirements, no matter how foolish they sound, then at least this provides the ability for a user to run AEM infrastructure within their own perimeter. And yeah, hopefully you're all welcome to use and contribute, and yeah, hopefully you can have a look at the platform solution. You can find us on amopencloud.io. I do apologize for the website because yeah, it's a placeholder at the moment. We're trying hard to find time to build the website. We also have a LinkedIn AM OpenCloud group. Some of you are already in the group. We try to post updates on what's happening with the project. And some of us actually also hang out at AEM Tech Slack group. So you can find me, Cliffano Subagio, or my another core contributor, Michael Bloch, on aemtechslack.com. So yeah, thank you. And I think we still have 2 minutes or 1.5 minutes for questions, if there is any.
Does this architecture use CloudFormation under the hood for provisioning the AWS VPC and other AWS resources?
Yes. So it provides several CloudFormations. So the AEM architectures are definitely CloudFormation stacks. There is also, I guess, an example network CloudFormation as well. But most of the enterprises, the slicing tend to be the user organization wants to control their network. They just want to run AEM within their network boundary, right? So the separation of CloudFormation allows them to do that. So they can integrate just the AEM piece within their architecture. So let's say one of our users has a slicing of like 5 layers of subnets, private subnets. Another user they don't care. Put them all in one private subnet, right? So it's configurable within AEM OpenCloud. So you can decide you want to put the author in the subnet or in that subnet. Yeah, that's up to you. So that can be done.
Could you say about the persistence options that you support, like Mongo segment as free data store? And for the segment, could you say how does it work with scaling? Like if you want to start a new publish and add it to existing ones, how it's synchronized with the other ones and so on?
Yep. So whether it's the creation of the environment or a scaling out or a recovery, the process is always the same. It attempts to find for the first time, there's a Genesis publish instance that is set up as the pre-base configuration. But as the environment lives on, and this is configurable, user can decide for, let's say, their nightly snapshot to be used as the base for the next recovery if need be. For the live recovery, so let's say if one of the instance terminates and a new one comes up, it takes a snapshot of the existing healthy published instance. And with EBS snapshot, that's quite fast. So it will just snapshot the whole AEM installation and then put it on the new published instance. Yep. And obviously, to answer your first question, it has to rely on the, the file system solution. But the configuration for the various OSGI configuration for AEM can be customized at a different layer. It's probably a bit too much for this presentation, but I think tomorrow there's a playground session, and I'm happy to walk through the solution there. Thank you.
Further questions? Well, then thank you for your talk.
Thanks a lot, everyone.